So that's just giving it a nice cleanup along this face and along this cylinder. Okay, so let's go to profiling. Now, you notice that we did have a lot of extra material in here. You're going to be, when you take this off of the CNC machine, you're obviously going to have to cut that off manually. So we're going to get a little bit more of that material out of there to make it easier and have a better finish on this end of the cylinder. So what we're going to do is we're going to do another profiling operation. And we're going to remove all those. And then we're going to go select this curve right here. And for the tool, we'll go ahead and use our 1/4 inch will be fine. Feeds and speeds, clearance, cut parameters, all this should be fine. On the side, we'll let it decide which side to put it on. Entry and exit, we don't really need any. Let's generate that. Okay, so let's go ahead and simulate. Well, let's see, we didn't get it. I'm not sure why that didn't regenerate.
Just change the side of the cutter.
See, well, we could try that. Okay, now it was on the right side. There it is. There we go. So now, what I was mentioned, you want to minimize how much you have to cut, but maximize the surface finish on the end of this part right here. Okay, so now we're going to get to our interesting 4-axis operation.
Before we go, hey Don, before we go into that, I wanted to, there was a good question regarding the offsets again. So if you go back to the program tab, again, Don here is using these offset curves for facing as well as engraving. He knew that he was going to use a 1/4 inch mill, I believe, to machine, so you had to offset that by the same amount. But in reality, what would have been a better approach would be to just use that intersection curve and use either profiling or pocketing rather than engraving. Profiling would have given the same finish, but you wouldn't have had to select or create the offset curve. Just like he created the profile on this end of the cylinder, you could have done the same thing on the other end. So
we can go ahead and do that.
Yeah, we can do that. And the same thing with the facing. I would have selected those two curves at the end and done pocketing rather than facing. I think the reason you did that, Don, is you wanted to clear the outsides of the material on the right side.
Yeah,
so,
yeah. Okay.
Yeah.
Yeah. So we can go ahead and do the profiling there. We'll show you.
It's basically the same profiling operation, but selecting the other. You can copy, paste it, and select the other curve, and it'll work.
We'll clone that. Remove that. We'll just do it on this one end. And let's generate, see if it's on the correct side. We got to flip it over. And then we'll go ahead and simulate that. Let's see, put that above the engraving. Yeah, so you could use a profiling operation. Yeah, good point, Joe. You don't have to do any offset curves. But you do need to make sure that your flute length is long enough to cover the largest width of the material right here. So as you can see right now, we have the top cylinder finished, the bottom, the base of this, I call it a pocket, is finished, but the side walls are not. So what we're going to do next is a profiling operation to clean up those side walls. So let's go ahead and go to the Program tab. And let's see, I'm going to look at my operation over here. We got profiling. We're going to go and select 4-axis profiling. Now, for the profile curve, we're going to select the edge of this pocket. We have a curve right there. So we're going to select curve edge region. We're going to pick that curve right here. So you'll see that that curve, let's see if I got the right one. Nope. Let's move that. There we go. So that curve is the base of that pocket all the way around, closed curve. And just like in 2-axis profiling, it's going to cut on either side. So let's go ahead and right click. And we're going to use, let's see, we're going to use the 3/16, 188. And we're going to go for the cut parameters. 1,000th tolerance, 0 stock, a mixed cut direction. And we're going to go ahead and allow it to determine using 3D model. So it should determine that it's going on this side and not the opposite. And let's see what else for the cut levels. We're going to locate it at bottom because our curve is at the bottom of the pocket or the bottom of the profile. And we could do multiple levels, but we're just going to do one level. So we'll set the total cut length to 0, rough depth 0, and the rough depth per cut at 0. So for the entry and exit, we'll go ahead and let's do a long path and none. Let's see what that looks like. Okay, so it looks like you put it on the wrong side. Let's try that again. Okay. So it created a profile, a closed loop profile around that entire winding surface. So let's go ahead and simulate that. So now let's turn the toolpath off. You'll see that we have a nice finished part, and that looks pretty good. I don't see any areas that need to be touched up on. We do, I don't like that, so let's change that. Let's take a look at the toolpath. See which one toolpath that was on. Okay, it was on the facing. So let's go ahead and double click on that. Engage and retract, we're just going to go none. Okay, and looks like that is it for this part. Is there any questions, Joe?
Yeah, there were a few that I answered, so.
Okay.
Yeah.
Okay. So let's go ahead and we're going to go to another part that I want to show you and talk about. Okay. Now, the reason that I picked this part is I wanted to make sure you understood how the tool is positioned in relation to the rotary axis. And all of the 4 axes except for the drive surface machining. We're going to show you that here as well. But all of the regular 4-axis operations, the tool is fixed in a certain way, and I'm going to show you how you can see that very easily in programming this groove here.